Alright, for homework 131, I'd like you to write down these problems and the key words. There's going to be 5 of them to let me know that you listen. Hopefully you do have graph paper and you're not making graphs on regular line paper, but if you do, try your best. But this is getting you ready for next week. This first one again, I need you to be the most solid at solving systems by graphing. That's the #1 way. So again, taking that blue line and that red line, solving them for y. So real quick, taking away that x, wave, wave. Take away 1x, that gives me the equation y equals -x plus 3. So that is a line with a y-intercept of +3 on the y-axis. Number in front of x, that slope, rate of change, -1/1, means from that point, right 1, down 1, right 1, down 1, right 1, down 1. Draw your line all the way through. We're going to take that blue line and graph that. Make sure you're stair-stepping both ways. Draw that line through. Alright, the blue line, in one single step I could solve that for y, so I'm going to add x to both sides. 1x plus 1x will give me that blue equation ready to graph. Y equals x plus 1. So again, be strong at graphing. +1 on the y-axis, over 1, up 1, over 1, up 1, over 1, up 1. This is a system of equations. Obviously, this is going to be one solution because they're intersecting lines. Make sure to get full credit. Give me the entire coordinate of that point. That point where they intersect is the coordinate 1 for x, 2 for y. 1, 2, that is the one solution. Plug in 1 for x, 2 for y works. 1 for x, 2 for y here works too. Next week, we're going to start taking these and again, take these system of equations and turn them into systems of inequalities. You have to know for Module 5 how to graph a system of inequalities. So for that, I'm going to take these same 2 equations, put an inequality in them. So instead of equal 3, this is x plus y more than or equal to 3. The other one, -x plus y, I put this inequality less than 1. So know that for these, you still need to show me the math to solve these for y. We're going to talk about when you divide by a negative number, how you got to flip that inequality. No flipping here. +3 is my same y-intercept, just like over here. My same slope, over 1, down 1, is my same rate of change. Now, before I draw my line, look at the inequality. If you have this equal line under there, that means all the points on the line are good. That means it's a solid line. Any point along that boundary is good because of that. This inequality is y is more than -x plus 3. To me, more than means no matter how the line's drawn, shade all the region above it. More than, shade above. So for this inequality, all the points above this line are coordinates that I could plug into this inequality and give me a number more than or equal to 3. Every one of these coordinates. Plug in 4, 4. 4 plus 4, 8. More than 3, yes. Any of these points are good. For the blue one, add x to both sides, gives me y less than x plus 1. If I have the line missing, that means your line is incomplete too. It's going to be a dotted line. That means points along that dotted line are no good. You cannot use them. So +1, over 1, up 1, over 1, up 1, over 1, up 1. Stair step the other way. That is a line drawn through them that you need to clearly show me is dotted. So clearly on your paper, make sure I could see it's clearly dotted. This inequality is less than, so less than to me is shading below. Surf, surf. So anything below that dotted line, not including that dotted line, is good to go. Now for this, you need to see that there are 4 parts of this graph. You need to find the 1/4 of the graph that has both shading zones overlap. I could see there's nothing here. This is going up, this is going down, nothing overlaps. This section is not it, because this is going up, but this is going down. No overlapping. Over here, same thing, going down, but this is going up. I could see in this quadrant right here of these 4 parts, this is the part where the shading zones overlap. Once you see that, I want you to fill in that just 1/4 of your graph. Maybe draw the lines so they're parallel to these, and these lines are parallel to the other one to make it look legit. I want you to see that any point in this shaded zone will satisfy both inequalities. Curl, curl. So that point right there, which is the point 3 for x, 2 for y, in both shaded zones, should satisfy both inequalities. So that point, which is 3, 2, if I plug in x is 3, y is 2 into either of these or the changed forms, will give me true statements. So here I go. Here's my check. Write this down. So the first check, plugging in 3 and 2 into the red equation, or not the red inequality, gives me 3 plus 2 is more than or equal to 3. That is a true statement. 5 is more than or equal to 3. True. When I plug in 3 and 2 into the blue equation, gives me negative, then put in 3 there, plus 2, less than 1. That gives me negative 1, less than 1. That is also true. Any point not in that zone would have not satisfied both. Alright, last problems. These, I want you just to practice all 3 types. So here we go. I'm going to have you write this equation 3 times, this set of inequalities. I'm going to duplicate it. Have you write 3 of all the same. Alright, for elimination method, again, adding straight down, this is set up for elimination because the x's cancel. Y plus y gives me 2y. 3 plus 1 gives me 4. Divide by 2. That gives me y equals 2. I could take that y is 2 and plug that not into x, but into the other equation's y. So I'm going to put that right there into the other equation's y and write that as x plus that 2 there where that y used to be, equal 3. Take away 2, and I can see that the x value is 1. Write that as a coordinate. That's the coordinate 1, 2. Alright, same set, but using substitution method. So the substitution method, solve the easiest one. Wash, wash. I'm solving this bottom one for y because in one step adding x, I got y by itself. And I don't got to worry about anything negative here. I'm taking that and plugging that not into the same y from the original, but into the other equation's y. So that gives me x plus, where that y used to be, I put x plus 1 equal to 3. Combine these two to get 2x plus 1 equals 3. Take away 1. And that gives me 2x equals 2. Divide by 2, and you can see that is x equals 1. To complete this, take that 1, plug it probably right in here, easiest one of all. So I have that as y equals 1 plus 1. Which is, of course, is the y equals 2 answer, just like that. Alright, if you're in my Math 1 class, you could skip this next problem, even though I know you know, and you know you're smart enough to do it. So this one, row reduction method, that is writing it without the x's and y's, just the coefficients, 1, 1, 3, negative 1, 1, 1. Those represent my x numbers, y numbers, answers. The first thing I'm going to do is leave this 1 alone and zero out the number beneath it. Whatever it takes to times this, to add to that, or to just add those together, whatever it takes, zero out that number underneath that top 1. And for this set, I could easily just add these two rows together and put that answer back into row 2 to start off. The top row stays the same. 1 minus 1, 0. 1 plus 1, 2. 3 plus 1, 4. Then take that bottom row, divide it by 2, or times it by a half, and put it back into row 2, which gives me the top row unchanged. 1, 1, 3. Bottom row 0, 1, 2. Now work from your bottom up, times this row by negative 1, add it to the top row. So negative 1 times 0 plus 1 leaves that 1 alone. That's why I'm doing this row. Negative 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 2 is negative 2, plus 3 is 1. That's where I'm getting those answers. So for that, x is 1, y is 2. Make sure you write that as a true coordinate. That's the coordinate 1, 2. Write that as a coordinate. Okay, almost done. Last problems. Again, your special cases. Here we go. So special cases, I need you to know for graphs, parallel lines, that's your no solution look. If I have two lines that are overlapping one on top of each other, that's your many solution look, or infinite. And then the last type, of course, is if you have two lines intersecting, that is one solution, one answer. Write it as a coordinate if this is the one that you're doing. And then the last two, again, I want you to see the looks to these when you're doing no solution, many solutions. If I add straight down and have everything eliminate and left with 0 equals and another number not equal, that's your no solution. That's another way of showing parallel lines. I promise these lines are parallel. If you do an elimination problem and everything cancels out, even the x's and the y's, even the plain old 4 cancels away, that is a infinite solution because everything cancels away and you're left with 0 equals 0, which is a true statement. That is infinite. And then, of course, the one you're most going to see when you're doing this combination method would be, oh, that is it. I didn't give you one. So the last word is rip. Rip. But going back to that last one, I want you to see that most problems when you're doing, they're not going to have the x's and y's both go away. You're usually going to have just the x's cancel and then the two y's add up to give you a 2y. Those are the real one solution elimination problems. All right, good luck. Hope you had a good weekend.